Alright guys, so by at this point you should have the 4 steps of how to find an inverse copied in your notebook. Just like I said on School Loop, do not write this in your homework notebook. Write this in your notes notebook, okay? So I'm just going to follow the 4 steps. I have a function f of x equals 1/2 x minus 1. And the first thing I'm going to do is replace the f of x with y. And what you see here on the video is exactly what is on the paper, but again, here I'm going through it step by step, whereas if you just copy the paper, you may not see what's going on, okay? You may not understand the steps. And then for step number 2 is we switch the x and the y. You swap them. And for step 3, you're going to solve for y. So that means we're going to add 1 to both sides. So then we have x plus 1 equals 1/2 y. So we need to get rid of the 1/2 because you want y by itself. So we're going to multiply by 2. Now be careful here. You have to distribute the 2. You have to multiply 2 by everything on the left side. Okay, and same thing here on the, oops, it's moving, sorry, times 2. So this becomes 1 on the right side. So you have 2x plus 2 equals y. And then for step 4, we switch out, once y is by itself, you switch that out for function notation. So instead of y, we're going to put f inverse of x equals 2x plus 2. So this is my answer for my inverse. Okay, so now I'm going to go ahead and graph it on the right hand side. I'll use different colors. Let me use black for the y equals x line. So I'm just going to draw the dotted line. Y equals x. Remember, this is the line of reflection, of symmetry. So this is the line where both functions are, this is the line of symmetry for f of x and f inverse of x. I'll use pink for f of x. So my y-intercept is -1 and my slope is 1/2. Okay, so -1 and the slope is 1/2. So it's going to go up 1 to the right 2, up 1 to the right 2, or I can go down 1 left 2, down 1 left 2. Okay, so again, just so you can see from any point, down 1 left 2, down 1 left 2, or up 1 right 2, up 1 right 2. And then we connect the points. Okay, it's a straight line. It might not come out very straight with the stylus pen, but you get the point, right? So I'm going to label this f of x. Oh, I forgot to I did label y equals x. I'll use green for the inverse function. And so my y-intercept is 2 and my slope is 2. So y-intercept is 2 and the slope is 2, so that means up 2 over to the right 1 or down 2 left 1, down 2 left 1, down 2 left 1. So the line goes like this. And as you can see, y equals x is the line of symmetry of the two functions. As I wrote in the notes, if you notice, the point -1, 0 has its corresponding switch, 0, -1. 2, 0 right here, 0, 2 up here. 1, 4 up here, 4, 1 right here. And then again, -2, -2, they have the same point in common because when you switch -2, -2, it's one and the same. -4, -3 is here as -3, -4. Alright, so example 2. copy the example in your notebook and then watch this video, and then you could go back and just copy the steps, or you could copy as we go through the video. It's up to you, as long as you have all the information that's in the notes in your notebook. So step number 1, we're going to replace f of x with y, and then for step number 2 we switch or swap x and y, so this becomes x equals negative 2 times y plus 3 cubed plus 1. Then we solve for y. So I'm going to subtract 1 from both sides. So this will be step 3. So x minus 1 equals negative 2 times the quantity of y plus 3. Okay, then we're going to divide by negative 2. So we're going to leave y by itself. That's the goal, to solve for y. So then you have x minus 1 over negative 2 equals the quantity y plus 3 cubed, right? So you've got to get rid of that cube. You cannot subtract 3 right now because it's inside parentheses raised to the 3rd power. But we can take the cube root of both sides. Okay, so the left side stays the same. The right side, on the other hand, becomes y plus 3. Because when you take the cubed root of a cube, you get rid of the radical. So now all we have to do is subtract 3 from both sides. So then you have negative 3 plus cube root of x minus 1. If you notice in the notes, I took out this negative because the cube root of a negative 1 is negative 1. So I took out this negative from inside the radical. You don't have to. I just did because it looks more simplified that way. So it would be negative 3 minus the cube root of x minus 1 over 2, like that. So step 4, once y is by itself, we just write it in function notation. Oops. Like this. You can write the negative 3 at the end, but I'll just keep it here in the front. Okay, like that. So this would be your inverse. So now we're going to go ahead and graph. Okay, I'm going to draw the line y equals x. This is my line of symmetry for both f of x and f inverse of x. So this is y equals x, and I'll just continue on the other side. Okay, I'll use pink for the points. Now I use transformations to graph f of x. My h is negative 3 and my k is 1, so that means that's my point. That's my inflection point, negative 3, 1. So I know that the graph is going to go through here. Oops. Through here. That's my inflection point. The negative reflected it over the x-axis, and the 2 made it a vertical stretch by a factor of 2. So you end up with a point here and a point here. Okay, and I used exactly what I showed you in class on Monday. When we went over the quiz, how we transformed the points. I used negative 1. Let's put it here real fast. Negative 1, negative 1. 0, 0, and 1, 1 to transform the points, and this is how I got the pink points, the pink ones. Okay, transform those. So here, again, as best you can, you're making a curve like this, and then like this. Okay, so that's a cubic function. So now, rather than try to graph this cubed root of x minus 1 over 2 and that f inverse of x as it is, what I'm going to use is I'm going to use the fact that inverses reflect over the y equals x line. And remember how we switch the points? So like for example, negative 4, 3 right here. Well, I know that f inverse of x is going to have 3, negative 4. So that's what I'm going to plot. 3, negative 4. I'm using green for the inverse function. And then right here, the point negative 3, 1, this point is now 1, negative 3. And then the point negative 2, negative 1 is now negative 1, negative 2, right here. Okay, and then we connect the points. Goes out like this. This goes up somewhat. Whoops. Accidentally stretched it out or zoomed in. Okay, so there's the graph of the inverse function. So this is f inverse of x, while the pink one is f of x. Okay? Alright, example 3, we're going to follow the 4 steps. So we have step number 1, write y equals x plus 1 over 2x minus 1. Step 2, we're going to swap the x and the y. So I've got x equals y plus 1, and you've got to swap it in both places. So the denominator is 2y minus 1. So now I have I can change this to a proportion, put a 1 underneath, and I could cross multiply, because now my goal is to solve for y, right? So I'm going to cross multiply like this. So I've got x times 2y minus 1 equals 1 times anything is itself, so on the other side I just have y plus 1. Let me distribute the x to 2xy minus x equals y plus 1. Now remember, your goal is to solve for y, so I'm going to put all my y's on the same side. So I'm going to subtract y, and then I'm going to move this x to the other side. Whoops, x not 1. So here this cancels, here this cancels, so I've got 2xy minus y equals x plus 1. Now I would need y by itself, so I'm going to factor out a y from both terms. And in order to leave this y by itself, I've got to divide both sides by 2x minus 1. So now I have left y by itself, so I could switch it out to f inverse of x equals x plus 1 over 2x minus 1. We got the same answer, right? This one looks exactly like the original. That happens sometimes. So let me show you on the graph why that's the case. So we're going to draw x is undefined when it's 1/2, because the denominator, x cannot be 1/2. So we draw a vertical asymptote at 1/2. So again, just approximate it about somewhere around there. And you're going to learn this later on, but there's a horizontal asymptote at x equals 1/2. Sorry, y equals 1/2, right there. And you just test different values of x. So I know if x is 1, plug it into the original equation. I'm plotting the pink one, the original. If x is 1, I get 1 plus 1 is 2. 1 plus 1 is 2 over 2 times 1 is 2 minus 1. So I get 2 over 1. So I get 2. And then if x is 2, 2 plus 1 over 4 minus 1. So that's 3 over 3, which is 1. So I get 2, 1. Okay, and I connect the points. Okay, it's the rational function, so we know it looks like that. On the other side, if x is 0, so I get 0 plus 1 over 0 minus 1, I get negative 1. So 0 minus 1. And if x is negative 1, negative 1 plus 1 over negative 2 minus 1, so I get 0 over negative 3, which is 0. So you connect the points. Okay, remember they're like two hyperbolas, two branches that look something like that. And when you draw the line y equals x, notice how the function is symmetric over this line. So it's symmetric over itself. So that is why we got the original function and the inverse being exactly the same. It doesn't always happen, this just happened to